All right, since I know everyone is here paying attention, everyone is excited to be here, right? Excited to be here. So let's start this off right. So class. Yes. A little bit more excited. I need some excitement right there. Help me out. To the edge. Yeah. Remember, you have to pretend like you're excited to be here, and at some point in time, you'll forget that you're pretending and actually be excited to be here. Okay. Thank you to me. Anyway, so constant speed velocity. So take a look at this. These are in the packets on the notes. So using positions, we could track an objective pictorially or graphically. That is going to be one of the big things that I try to have you do for this class all year long. Draw a graph, draw something to represent that problem. Because everything we do is going to be a word problem where you have to understand what's it doing. Is it going to the left? Is it going to the right? You know, all these things you need, and that's going to set up more after you actually have all those things. In the figure below, each arrow represents 1 second of movement. Each arrow is 1 second of movement. And the first set of arrows see that the objective covers equal displacement in equal times. Therefore, we can say that the object at a constant speed or constant velocity. Now, 1 second. So this first one, it takes 1 second to make it to the first distance, right, to the 1. Another second to go to the 2. Another second to go to 3. Another second to go to the 4. Another second to go to the 5. Each one of those is equal. They're all the same. If I were to draw this on a Cartesian, the XY coordinates, it would be a straight line. It would be a straight line. It would be a linear equation where any point on that line has the same slope. And we know that slope is the velocity. It's the change in distance over the change in time. So it's just the slope. The slope of that line is my velocity, my change in distance over the change in time. Now for the next one, we're going to have right here, 1 second. It's not all the way to the 1. 2 seconds, it makes it to the 1. 3 seconds, it's almost to the 2. 4 seconds, it's a little bit past the 3. 5 seconds, it is all the way to the 5. Now, what can you tell me about this bottom line, the bottom one? Are the arrows the same? Say no. No. Okay. Now, what else can we say about it? Give me descriptions. Tell me what it's doing. It's what? It's going slow. It's going slow. So right here, it's going slow. What about over here? It's going faster, right? So what can we say about that? Its speed is increasing. Very good. Now, if the speed is increasing, what's the special word we have that if my speed is increasing? It is doing what? We only have a handful of vocabulary words, and it is one of those. If my speed is increasing, then it is accelerating. It's accelerating. So the rate of change, the slope, is actually increasing as we go. So it is accelerating there. So it's going faster. So the lines are getting longer. So the bottom one right here, that it is going to be accelerating. So this bottom should be like the right side of a parabola. It starts off going slow, but increases as we keep going. Where the one above it is a linear function. It's going to be a straight line, go all the way through. Average acceleration. Average acceleration. Can someone tell me what that line on top of the A is called? Huh? That's what it means, but what's it called? There's a name of it. And if I didn't know, I could sit here and just wait until someone else actually gives the answer, or I could scroll back a little bit in the notes to see where it is. Not implying that anyone is sitting around and just waiting for someone else to give an answer, but actively participating is helpful. Huh? Not vector. What the thing on top? The thing on top of the A. Very good. It's bar. It's called a bar. That's important. It's a bar, and it means that it's the average of that. So as I'm writing my notation, average acceleration. That's important. Average acceleration is the change in velocity over change in time, or just the final minus initial over whatever time is changed there. Now, you people, write me out. A truck accelerates from 10 meters per second to 30 meters per second in 2 seconds. What is its acceleration? This is something for you right now. Write that out. So I should see everyone scribbling something in there right now. At least attempt it. The same formula that's right above it. Very good. Okay. Good. Good. Oh, yes. Good nurse. Leap on for this guy. Yep, you're doing that. What formula are you using? Yes. All right, on the board here, let's see. So, final velocity. So what is my second velocity in this case? 30, very good. So it's 30 meters per second minus 10 meters per second. My time? 2. This one right here isn't like the coordinates like they give you here, where it says final and initial. It just says in between these 2 points, it takes 2 seconds. So delta t means your change in time. So here it gives us what it is. It says our change in time is t. That's what that means. So my delta t is just 2. So that's going to give me 20 over 2, which is 10. Now, notation. What are my units? M, S, two. Why? Acceleration is always going to be per second. So it's second squared. Acceleration is always, and you do not write that down on a free response question, you will be incorrect because you're no longer talking about, if you don't put that 2 right there, you're no longer talking about your acceleration, you're giving me an answer in velocity. It means something different. So I need you, pay close attention, make sure you write your units, write it all out. Suppose the truck slows down to 5 meters per second in 4 seconds. What is acceleration? Now, you are going to do this one right now, too. Do it. Do it. Right. Oh, okay. Sorry. You could also write over here. I'm sorry. I'm just checking. Okay. Walk around. Shut. Okay. So, what's your final velocity? What's your final velocity? One. Okay, so as we're reading, it says what? 2. Okay, so my final velocity is going to be. Okay, and what was my initial velocity? No trading. It's the same truck because we're talking about that same problem. So that's where you start there. So it's going to be your initial in this case is 10. So it's not the 10, that's acceleration. So it is the 30. I had about this, sorry. There, right? This one is acceleration. That's 4. All right, for this next problem, okay, just so you don't mess this up, that is your average acceleration. So for the next problem, what was my velocity, my initial velocity? So we're here, right? The truck, because we're talking about the same truck, right? It goes from 10 to 30. Same truck, then slows down. So my velocity is 30 at this moment. Then it slows down. So the initial velocity of this truck for the second part of the problem is going to be 30. And the final velocity is going to be 5. So it would be 5 minus 30 over how long? 4 seconds. So that's going to give me a negative 25 over 4, which is a negative 6.25. And my units are meters per second squared. All right. Did I blow you guys' mind on that one? Was that one too crazy? What part of that did you not like? Jackie, you're like shaking your head at me. Did you not like that problem? Oh, okay. It's just in general. Juliet, were you shaking your head at me? Did you not like that one? Yes, you didn't like it. What part of that did you not like? The 30, right? Okay, because why did you not like the 30? You thought it was going to be 10. And it would be 10 if I did of the entire thing, right? It would be 10 if I did the very start, if I did that one right there. Okay. Now, if I did that, so it would be a 10 there, and it slows down to 5. So we would actually go 5 minus 10 over, what would my time be? I heard it? 4. Not 4. 2. It would be, no, 6. Because we would start over here at this. But we're just talking about that second part here, from where the point that the truck slows down. So when the truck starts slowing down, he was at 30 meters per second. Does that make sense? Because from here, it actually goes 10 meters per second up to 30 meters per second. And from that point, it goes down to 5 meters per second. So it speeds up and then slows down. And we're just talking about the point from 30 to the 5 is the acceleration from there to there. Does that make a little bit better sense? Yeah. So next. All right, let's keep going. Now I'm gonna draw a little graph to try and help you with this, because this is going to be quite possibly the most complicated thing that everyone's going to have trouble with. Now, you guys are going to draw a little graph to actually show this one. So, positive velocity would be going in this direction. That's a positive velocity. Now, at this point right here, it's still moving to the right. It changes direction. That would give me a negative acceleration. You agree? So I'm still moving to the right, but I am slowing down. So, according to time, I'm still moving to the right, so it's a positive velocity, but slowing down. Now next, at this point, instead of doing that, a positive acceleration. So that means that my velocity is going to the right and my acceleration is positive. So I am increasing at an increasing speed. Does that make sense? So when we say a positive velocity and a positive acceleration, okay, then it goes up here, increasing and increasing. Now the next one, I'm going to go in the other direction, so it's going to be a negative velocity. If it is a positive acceleration, but in the negative direction, it's slowing down. If it is in the negative direction and it is a negative acceleration, it's speeding up in the negative direction. Now, hopefully this diagram actually helps, especially for people that, are visual and actually go back and try and see these things. But others will not take notes. They'll sit there and stare at me awkwardly and wait for me to tell them, write this down. But I'm not implying that we have anything in here like that. Because you ain't heard it from me, because I ain't one to gossip. At the right. All right, so now this is what it's talking about, the signs. Okay, these two diagrams explain going directional. Suppose the ball is thrown straight upward at 40 meters per second. It takes 4 seconds to reach its maximum height, then another 4 seconds going back down to the point where it is thrown. Assume it is caught with the same speed it was thrown. Calculate the acceleration upward and downward. So, as it's going up in height, right? Say yes. It's going up in height. But what's happening as it's going up? There's just one law. It's what? Going down. So what must up? Should keep going up? Going down. Goes down. Is that a law? Gravity, right? Gravity. So there is that. So it's going up, but now, is it just keep going up and it keeps going up faster and faster and faster? Say no. No. What's happening as it's going up? What makes it eventually come down? Gravity, but as it keeps going up, it's slowing down, isn't it? Okay, so it's a positive velocity, but it is a negative acceleration, so it's slowing down. Okay, that's good to know. Now from the other way, from the peak of this going down, my velocity is going to be, because it changed direction, didn't it? So it's now going down, and the acceleration is going down also, right? So it's going down at a faster speed. Okay, negative sign came from using the delta for the first one, going upwards, but downwards, okay, we had to make this because negative sign came from the direction of the velocity. Velocity is a vector. It is going down. So you get a negative answer both ways, as gravity acts downwards no matter if the ball goes up or down. It's gravity which changes the ball's velocity. Now, this is what we're going to do right here. You're going to draw it out. You are going to try and do this. You can talk with your group. You guys could talk about it, work it out, but first thing you do is try to draw a diagram of this. It's muy importante. It's very important. And go. What do you think? We'll deal with the football problem. Something like that, yeah. So, but if we. Yeah, so it's just gonna go there, and that's fine. So we can do it on number one. Yeah, you don't have to have a 2B. That's a graph for your trying to understand the definition of the positive, negative acceleration. Don't worry, you're not the only one that has to do this. Looking at a whole bunch of squares right now. Your endpoints. That might help. All right, so on the board up here, I'm going to start with my diagram. And we have Baltimore. And we have DC. Now, what do we know about this? So I'm just drawing a, you know, if you want to draw a train, you're awesome. I'm horrible at drawing trains. Anyway, what do we know from that information? It goes back and forth. Very good. So it goes from here. So it starts there. Starts in Baltimore, right? It goes there, and then turns around and goes back. Okay, that's important. What else do we know? Okay. I hear two things. You said 40 miles from where to where? So in between the two stations, right? Okay, that's good. And what'd you have? In an hour and 45 minutes. So that represents my what? Very good. I'm going to label that T. So my total time, I'm going to put a little T next to it also. So total time, 1 hour, 45 minutes. I don't like having mixed numbers. I really don't. So give me that in minutes. 105. So it'd be 105 minutes. Okay, so we're looking for the average velocity. So how far did he go? So right here, going from here to here, that is a positive velocity. And that is a negative velocity. A positive velocity and a negative velocity. So if it's positive going that way, negative going that way, that's weird. I'll let you ponder on that. Let's go with the speed. I think that one's the easier one. Speed is the total distance over time, right? Distance over time. What's my total distance? 80 over 105. All right, I'm going to pull up my calculator right here. Let's say 0.762. What are my units? Is it asked for acceleration? Yeah. Meters per second. So it's distance over time. So I'm going to leave off there, and I'm going to pick up the rest of this tomorrow. It's the same place I left off from the other class. I'm just running out of time. So remind me to pick up at the same thing tomorrow. All right. Make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff for the merch store. And